This is llama.cpp, large language model inference written in plain C and C++. It runs modern LLMs on your own laptop, with no Python and no required dependencies. The goal is local inference on commodity hardware. A single self-contained codebase that compiles to a native binary and runs a quantized model on a CPU or accelerates it on a GPU when one is available. It comes in 3 layers. ggml, a minimal tensor library, sits at the bottom. The llama runtime builds the transformer on top of it, and a set of tools, like llama command line and llama server, expose it to users. Architecturally, each layer depends only on the one beneath it. ggml knows nothing about language models. llama knows nothing about command line flags. That separation is why the same engine runs on a phone, a laptop, and a server. Start at the bottom. ggml is a small tensor library written from scratch in C. Everything the model does, every matrix multiply and attention step, is expressed as operations on one core struct. Here is that core struct. A tensor carries its data type, its shape as a list of dimensions, its strides in bytes, the operation that produced it, and pointers to the source tensors it was computed from. Those source pointers are what wire tensors into a graph. Because each tensor remembers the operation and the inputs that made it, the whole forward pass is a graph. ggml first builds that graph symbolically, then hands it to a backend to execute. Build first, run second. Models are distributed as a single GGUF file. One file holds the quantized weights, the architecture metadata, and the tokenizer together, so a model is one download you can memory map straight off disk. Quantization is first class in the type system. Alongside 32 and 16-bit floats, ggml defines a whole family of integer block quantized types, from 8-bit down to under 2 bits per weight. Picking a quantization is a size versus quality dial. Full 16-bit weights are largest and most faithful. The popular Q4KM sits near 4.5 bits with little quality loss. Q2K shrinks the model the most, but degrades it the furthest. Now the runtime. Generation is autoregressive. The prompt is tokenized once, then the model produces one token at a time, and each new token is fed back in to produce the next. This is the entire generation loop. Call llama decode to run the transformer on the current batch, sample one token from the result, stop if it is an end-of-generation token, otherwise turn it into text and pack it into the next single token batch. Drawn out, the loop is a simple cycle. Decode the batch, read the logits, sample a token, append it, and repeat until the model emits end-of-generation or the length limit is reached. What flows into llama decode is a batch. It bundles the token IDs, their positions, and the sequence each one belongs to, so a single decode call can advance many independent conversations at once. Sampling is composable. You initialize a sampler chain and add stages to it. Here, a single greedy stage that always takes the most likely token. Swapping in temperature, top K, or repetition penalties is just adding more links to the chain. Acceleration comes from ggml's backend abstraction. The same compute graph runs unchanged on a plain CPU, on Apple Metal, on NVIDIA CUDA, or on Vulkan. The backend just supplies the kernels. That gives broad hardware coverage from one codebase. CPU everywhere as the baseline, Metal on Apple Silicon, CUDA on NVIDIA, and Vulkan as a cross-vendor GPU path. On top of the runtime sit the tools. Llama command line runs a prompt or an interactive chat from the terminal, and Llama server exposes the model over an open AI-compatible HTTP endpoint. Stepping back, one C and C++ codebase, with no required third-party libraries, supporting dozens of model architectures, integer quantization from about 1.5 up to 8 bits, and a handful of GPU backends. The deeper lesson is one of engineering discipline. By owning the tensor library and the model format, and refusing outside dependencies, llama.cpp made local language model inference portable to almost any machine. That's llama.cpp. From the ggml tensor struct, to GGUF and quantization, to the decode and sample loop that turns a prompt into text, on whatever hardware you have.